Each of the following tables contains values representing either linear or exponential functions. Find the equation for each function. What we need to recall for this exercise is that for a linear function, the output increases or decreases by a fixed amount for each unit increase in the input. And for an exponential function, the output increases or decreases by a fixed percentage for each unit increase in the input. So notice that for table A, the x values are going up by 1. That means that there's a unit increase in the inputs. We need to determine whether the output is increasing by a fixed amount or by a fixed percentage. If it increases by a fixed amount, then there'll be a constant difference between consecutive outputs. So let's check and see what the consecutive differences are. If we take 2.8 and subtract 1.12, then we get 1.68. If we take 7 and subtract 2.8, our next two consecutive outputs, we get 4.2. Notice that the differences are not the same. That tells us that the output is not going up by a fixed amount. This is not a linear function. Let's check and see if it's exponential. In order to check and see if a function is exponential, we need to check and see if there's a constant ratio between consecutive outputs. So we'll take the second output, 2.8, and divide by the first output, 1.12, and that gives us 2.5. All right, let's take our third output, 7, and divide by our second output, 2.8. That's also 2.5. And if we continue, 17.5 divided by 7 and 43.75 divided by 17.5, we see that each time we get 2.5. That means that the output is increasing by 150%. 2.5 is 1.5 more than the number 1. So there's a 150% increase in the outputs as the input increases by 1. So that tells us that f of x is an exponential function. So for part A, we'll write down the form of an exponential function. It's f of x is equal to c times a to the x, where c is the initial value and a is the growth factor. So in this case, we have f of x is equal to our initial value. For our initial value, we locate where x is 0. When x is 0, the output is 7. So 7 is the initial value. F of x is equal to 7 times our growth factor. Well, we've determined that our growth factor is 2.5. That's what we get when we divide consecutive outputs. So times 2.5 raised to the x. Well, let's double check and make sure that it works. Let's go to y equals and enter 7 times 2.5 raised to the x. And then we'll create a table and make sure that the table matches the given one. So go to table set, which is second window. We want to start at x equals -2 and increment by 1 and have the table automatically fill in for us. So make sure that the independent and dependent variable are both on auto. And then go to table, second graph, and notice that the outputs are the same. 1.12, 2.8, 7, and so on. So we've come up with a correct function. Let's go back to our home screen. And let's work on part B. We want to check and see, is there a constant difference or is there a constant ratio? Well, this one I think we can just do mental arithmetic and see 0.3 minus 0.1 is 0.2. 0.5 minus 0.3 is 0.2. 0.7 minus 0.5 is 0.2. There's a constant difference between consecutive outputs, and so that tells us that g of x is a linear function. So let's write down the form of a linear function. For part B, we have g of x is equal to ax plus b. And what we want to recall is that a is our constant average rate of change and b is our beginning value. So for b, we get g of x is equal to our constant average rate of change is that constant difference of 0.2. So we get 0.2 multiplied by x plus our beginning value. Well, to get the beginning value, look to see where x is 0, the corresponding output is 0.5. And again, double check and make sure that this actually works. Let's go back to y equals. We'll clear out our first function and enter 0.2x plus 0.5 and then create a table of values. And notice that the outputs correspond. When x is -2, the output is 0.1, and then we get 0.3, 0.5, 0.7, and 0.9, just like the given table. So our function is correct.